see you after lunch. Hopefully we'll have a great session this afternoon. Just to remind you, in case you're thinking of dashing away, we hope you can stay for drinks and sushi, I think, as well afterwards on the terrace. So, looking forward to drinks in the evening as well afterwards. And I'll hand right over to Leo now, who I don't think needs any further introduction. Mr. Karistios.
Okay, thanks, Nick. Okay, welcome back, everybody. I know it's very difficult to present, so I have to thank the previous presenters of the morning session, so that you don't feel that we ask you to do the hard job. I decided to stand in front of you and spare 15 minutes of your time, actually giving you a bit of an overview of how we see the LPG shipping sector, the markets and the technologies. So my agenda, it's going a little bit of the commercial. I know we have a lot of commercial analysis after my presentation. Look about the LPG overview of the technologies, touch a little bit on new construction and see the future developments, although I have to admit the LPG shipping sector is more conservative than other gas shipping sectors. So we, as Lloyd's Register, we are not experts at all at doing any market analysis or making any forecast, but we try to understand what's happening in order for us to be positioned well on the moves of the specific shipping sector. So we know that we are living in difficult, let's say, times within marine, but if we look things at the long term, despite of all these crisis, the long-term forecast for LPG remains fairly healthy. There will be supply for more cargoes. This is driven very much by US. There is also the demand that has to absorb, which this slide looks like the supply and the demand follows each other. So that means that there's a lot of opportunities to utilize what some people consider as an abundant source of energy. The drivers that forms this forecast are kind of like regionally segregated. For one, we have US becoming an LPG exporter. At the same time, US has had its own demand needs. Therefore, we didn't see a huge boost of US cargoes to Asia and Europe. There will be opportunities in trading LPG in the Atlantic Basin, and one of the advantages, or one of the markets that the LPG is trying to penetrate is petrochemical industries. In terms of Asia, they have expressed, we have seen in the last 2 years, but it's still moving forward, to have increasing demand for LPG importing. There is also entering into the petrochemical gases, specifically in China. And Europe is going to play also a role, as we've seen before, that the use of LPG is quite wide. It becomes wider and has a lot of practical utilization on the power grid, or at least in the as a source of energy in the houses. Specifically to the shipping, there is a significant amount of order book with deliveries in 2016 and 2017, which accounts to 93% of the total LPG order book. After that, you can see there's a vast drop of LPG deliveries. Primarily, focus of the LPGs for 2016 and 2017 is the large LPG carriers above 60k. Most of them are also usually called very large gas carriers, VLGCs. Regarding the new building capacity, we see that most of it is focused in Asia. We have South Korea, Japan, and China leading with 51.3% of the global LPG order book. Regarding the growth of LPG fleet, it is expected, because we have increased supply, we have increased demand, it is expected to grow by 41.2% from now until 2025. If you notice on this graph, the orange bars below suggest that there will be a number of demolitions of LPGs, not because of any financial situation that we have on other shipping sectors, but because we see that, well, actually the analysts see that there is old tonnage in the market that will have to be replaced by the significant order book that we have for 2016-2017. Forecasting the new building contracts is something that is very difficult to forecast. All these market analysts are trying to demonstrate that in the past they have been very successful. I can tell you for sure that if you go back a few years of the forecast, they were wrong even in 2015 and 2014. And also they forecast different contracting activities for the next 10 years. The one in dark blue is from Clarksons, which you see a large number of LPG contracting activity for the next 10 years, while MSI is a little bit more conservative. But nevertheless, it looks like it's going to be healthy activities both for shipbuilders and ship owners, specifically driven by the supply and demand for LPG. And since this is a Lloyd's registered event, allow me to position LR where it stands based on the data other market analysts hold, which brings us into a market share of 28.2% of the whole global fleet. And specifically on the LPG global order book, we hold 32%. So this is the market. Now we move a little bit about what the general overview of an LPG carrier. So we discussed in the morning a lot of things about specific equipment that constitutes an LPG carrier, especially for the cargo handling aspects. I will go a little bit on an overview of other areas like the hull, the design of cargo tanks, and how an LPG carrier is typically classed. So here in this slide, just an example of a Type A LPG carrier, how it is classed with the Lloyd's registered class notations. And I highlighted specific words which not only affect how the vessel operates, but also affects the design of the vessel. So the description of the tank, what is the design pressure, the design temperature, and also about refrigerated cargo installations and equipment. So the dominant LPG carrier designs is that of membrane system, which actually have received an approval of the previous, of the main, let's say, products, which is the NO family and the Mark III family, which primarily has been used on LNGs and recently on VLCCs. Obviously, I have to update my slide, Mr. Colson, and introduce a nice image of your new containment system for LPGs that you presented today for us. For large LPG carriers, we are talking about Type A, which is an independent tank. Type B tanks have been used in the past for LPG cargoes, but they have dominated the LNG market for a number of decades. And then for smaller LPG carriers, Type C is dominating, which is semi-pressurized at 5 to 6 bar G and semi-refrigerated. The arrangement of the longitudinal profile of an LPG carrier versus between a Type A and Type C looks like that. There's not a lot of differences, except that in case of a Type A, a segregation between the engine room is required by COFETA. How is the principal operation of an LPG carrier? It's not that complicated. Basically, the pumps are installed inside the cargo tanks, and then using booster bulbs normally go through a cargo heater or not straight to the manifold. Because the LPG is liquid in cryogenic conditions, obviously we have vapor generated inside the tanks, increasing the pressure of the tank, and in case of an overpressure, there are safety valves, and then the gas can go through the masterizer. It's basically a means of safety with the cargo safe design. When the LPG becomes gas, obviously you lose cargo, and obviously it's valuable and it costs money. Therefore, the LPGs are equipped with refrigeration plants. The schematics of the common refrigerating plants is of direct type or cascade type. Of course, this is just a very outline description. We have seen in the morning further improvements that have been done for more efficient ways of handling the cargo. Another feature of the LPG carriers is that, and general gas carriers, but specifically on LPGs, is the inert gas system, in order to ensure that there is no oxygen inside the cargo tanks, to minimize or to eliminate, the risk of any explosion or fire. And lastly, it is important to understand and classify the hazardous areas of an LPG carrier, slightly different between Type A and Type C, because this affects a lot of the design and the construction of the electrical equipment on board an LPG carrier. So a little bit of moving on to the new construction stage, which doesn't start at the shipyard. Obviously, it starts at the design offices first. It could be at the design office of the shipyard, and what the Glass Society's role is on this. Basically, the whole using finite element methods, the whole ship is assessed at the specified load conditions, and then it's assessed using what we call shipwright SDA procedures, structural design assessment. Moving on, there are critical areas which, in accordance with our procedure, have to be analyzed at even up to, for fatigue, even up to a level 3. Considering again the operating profile of the vessel, whether it's worldwide, North Atlantic, and for how many years fatigue life is required. This allows us to identify critical areas on the structures of the vessel, which denote, which actually guides the shipbuilder and the on-site surveyors to monitor the construction of these critical areas as a result of this detailed and rigorous analysis which is done at the design stage. So this is what a Type C bi-lob LPG design looks like. An important feature is that the progress of the vessel goes hand in hand with the construction of the tank, and the hull basically has the required structure to support the tanks, which have to remain independent from the ship's hull. In case of Type C tank, LPG carriers, generally Type C tanks are not required to have secondary barrier as defined by the IGC code, and the use of low temperature steel is used for the construction of the cargo tanks. In the case of Type A, it's similar concept and thinking. It's an independent tank constructed outside of the vessel's hull. As the vessel's hull is assembled and erected, then the cargo tank will be positioned to its supports. In the case of a Type A LPG carrier, it is required to have a secondary barrier. And the secondary barrier, and for that reason, the ship's inner hull is acting as the secondary barrier. Therefore, it is constructed also by low temperature steel. In case of low temperature steel structures, it's not rocket science. We're not talking about a totally unfamiliar to the shipbuilders material, but it requires some special attention. So just to give you an example of what kind of amount of work we are looking here, every weld is identified in a weld map, the technique, the methodology, and all the parameters required. All non-destructive examination is very important, and the volumetric, i.e. RT and some UT techniques are required for the whole boundary of the cargo tank. And in addition to that, in order to ensure the mechanical properties of all the welds, with the use of production of weld test pieces, as we call them, they go through mechanical testing, which ensures the quality of the weld. The amount of inspections required, or we carry out on an LPG carrier are much higher than any other ship type. There's a lot of fit-up inspections, following up the any repair if it's required, etc., etc. So before starting the construction of an LPG carrier, it is important that the shipbuilder demonstrates capability in building these kinds of vessels and being able to, I don't think it's me, okay. Thank you. And this basically entails that welders needs to be certified, and new WPSs specifically for low temperature steels needs to be developed and approved, plus approved repair procedures. The cargo tank installation is an important element on an LPG carrier. Basically, it's to reduce the boil-off that is generated, and also with an effective cargo tank insulation, it requires less running hours of the reliquefaction plant, and in some cases, especially for the Type A LPG vessels, protects the secondary barrier. The method of applying the foam is either by spray, or in the old days it used to be by pouring foam around those metallic sheets. And in case of spray, this let's say elastic polymer that is applied is acting as a vapor barrier. How the tank is supported, I explained earlier, in terms of hull is a critical area, but in how you support the tank and how you balance the weight of the tank at different loading conditions, considering also the different movements of the vessel, it's very important. And the characteristics here is that it's not only about supporting the tank, it's also about protecting the ship's structure from the tank's movements. And in case of the tank floating, by using these anti-floating supports. The cargo piping on an LPG carrier is mainly found on deck. That's the reason why we use submerged pumps inside the tanks. And the material is stainless steel, and it's of welded type. Due to the cryogenic conditions of the cargo, the arrangement of the piping should allow thermal expansion and contraction. And again, a significant amount of NDE is required during construction of an LPG carrier. There is also a very important role in the whole operation of the LPG carrier through the compressor room and the electric motor room. Those rooms have to be separated in terms of an airlock. It has to be gas tight and also have specific distances to be apart. And again here, because we have a bulkhead separating the compressor with the motor, the alignment is very important, and this is a check item during the construction of the vessel at shop and on board. In terms of the inner gas system, okay, it requires to be tested, but normally these are provided with a type approval certification. Nevertheless, the safety and operation test has to be carried out on board for the effectiveness of the inner gas system. A common trial, on normal ship types we have ship trials. In case of gas carriers we have sea trials and gas trials. In case of LPG carriers, the gas trials take place after the delivery of the vessel, where there we have the opportunity at the first loading to see the overall performance of the cargo engine systems and the cargo handling equipment. And another item is to check for any cold spots of the cargo tank insulation in case of any defects. Lastly, there have been, it was mentioned before that the LPG carriers are designed at -50, and this was also considered sufficient to incorporate limited percentage of ethane on LPG cargoes. However, we have seen that the percentage of ethane has been increasing the latest let's say trading of LPGs to 8%, which means that the design pressure should be below -52 degrees. For that reason, there are a number of ways that you can make the vessel compatible to load LPG cargoes in that amount of ethane. I'm just presenting an example which LG gave more details the morning session about the vent gas cooler. And lastly, we believe that the LPG as fuel is something that's going to happen. It's going to become standardized. It is common sense to have the ability to use the gas generated from the cargo tanks in fuel. The technology is developing, it is there. We have also approved in principle with MAN the ME LGI engines, and I have to say this is quite innovative because it is found that the standards and the legislation were not there at the time when we do this exercise, and you have to come up with innovative ways of checking the reliability and safety of a system, and for that purpose we have the ShipRite risk-based design assessment approach. And with that, I close my presentation. If you have any questions, thank you.
Any questions for Leo?
I think we have it here.
Where society should be directed, for LNG, burning ships, or LPG?
Okay, so my view, yes, my view on this is that gas carriers, it's better to burn the gas they are carrying. Okay, so LNG carrier burning LNG, LPG carriers burning LPGs, ethane carriers burning ethane. It makes sense commercially, and also has a lot of implications also on the capex of the vessel and the opex of the vessel. Because you introduce less equipment, if this is where I'm getting at. In case of other ship types like bulk carriers, tankers, containers, passenger ships, the developments from technology point of view, LPG is possible. Okay, methanol is also possible, but there are other elements within that whole supply chain, bunkering infrastructures or facilities, etc., that the developments are faster and, let's say, more solid, if you want, on LNG. Okay, so I see that it will be very difficult for LPG and methanol I'm not going to say, because I know that EU is supporting methanol as well, and there are other initiatives, but LPG or other gases cannot easily compete with LNG because of all the other supporting let's say technologies you require, as I said, bunkering, etc. Plus, especially in Europe, there's a huge support to make the LNG another competing fuel for ships, like oil-based products used to be up to now. One question we have here at the front.
Actually, it's a very small point regarding burning LPG as fuel. We must never forget the auxiliary engines. So we might have the main engine able to burn LPG, or in our case, with the gas reformer, to burn LNG, but we must not forget the auxiliary engines, which I think in all cases they cannot burn LPG.
Yes, you are right on this one. Okay, we have to wait and see. I mean, from the technology point of view, I think theoretically it's possible, but we haven't seen companies like yourself investing on that so much to say that it's reliable. So I guess what I see is that the next generation of gas LPG carriers will be the main engine, main propulsion using LPG as fuel. And then later on we will see potentially the auxiliary engines also utilizing, basically following what a typical LNG carrier is. That's how I see it, but yeah, there is some work to be done there, yes.
Okay, thank you very much, Leo.
Thank you.
So our next...